Okay, good morning, ladies and gentlemen. The date for today is January 8, 2024, and the time is 2:43 a.m. Okay, my topic for this session will be a continuation of my trigonometry long video format topic. This is trigonometry, and we are now on lesson number 46. Okay, let's proceed. The subject matter for this morning, life must go on, okay? The subject matter for this morning will be trigonometry, lesson number 46. This will be a continuation of the last lesson number 45. Lesson number 45 is actually a problem on oblique triangles by using the so-called SINE law. So for this morning, I will be presenting a second solution or an alternate solution to the SINE law solution. So we could verify if that SINE law solution was actually correct or not. So for this morning, we will be solving the same problem. Okay, so the title of the topic will be Problem on Oblique Triangle using the so-called conventional solution. Conventional. Conventional solution is just the so-called solution by just using the plain definition of trigonometric function, that is the sine, cosine, tangent. Because under the so-called SINE law solution, that was a special case solution. Okay? It was a simplified solution for oblique triangles. And for this morning, I will be presenting an alternate solution so we could verify if the answer from the SINE law solution was actually correct or not. Okay, let's proceed. The problem was the same as from lesson number 45. We are given an oblique triangle. Oblique triangle meaning the sum of all the interior angles inside is actually 180 degrees. That is the sum of angle A, angle B, and angle C is equal to 180 degrees. And one of the angles is not actually 90 degrees. Because if one of the interior angles is actually 90 degrees, it falls under right triangle. Since the angles are not actually, one of the angles is not actually equal to 90 degrees, we could say that the given triangle is actually an oblique triangle. So what is given here is we are given angle A, angle B, and we are given side C. Side C is 30 inches. So the problem is just asking what will be the value of angle C, what will be the value of side B, the side opposite angle B, and what will be the value of side A, the angle opposite angle A. So in here, like what I said, we try to find for angle C, side A, side B, and we are given side C, 30 inches. Angle A is 38 degrees and angle B is 71 degrees. So we are given, how many is given? Are given. We are given three parameters. Two angles in one side. So we are looking for the third angle in two sides. Okay, let's try to bring out the solution by using the so-called conventional solution. We'll try to compute for angle C. We will be using this formula. For any oblique triangle, the sum of the interior angles is 180. So angle A, B, and C is 180. Angle C now will be 180 minus the value of B and C after the transposition. So this should be 180 minus 38 minus 71, or 180 minus 109. So angle C is 71 degrees. Same as from the previous solution, we could not do anything about that. Under the SINE law, the value of angle C is still 71 degrees because we presented the same solution. But in the computation for the value of side B and side A, we will be using the conventional solution without using the SINE law. Okay? There are two right triangles here, right? because originally the dotted line was not present, so I just dropped the vertical line. Okay, so this vertical line here, the dotted line, is actually perpendicular with respect to the right triangle and the left right triangle. This is in 90 degrees, and so it is. So we represent the altitude of the oblique triangle to be h. For the meantime, we do not know the value of this. And we will represent this length here. Okay? The right triangle portion to be x. For the meantime, we do not know the value of x. So if this value here is 30, and this is x, this portion here should be 30 minus x. And also for the meantime, we do not know the value of this. So actually, if we try to bring out the conventional solution, there will be two unknowns. Okay, it will be h and x. So we could compute for a and b. Because as soon as we compute for h, we will use the sine function to compute for side b. And again, after computing for h, again by using the sine function, considering 71 degrees, we could compute for a. So at least we know in which direction we are going if we try to bring out the conventional solution. So by using the left triangle, this portion here, I will cover this one. Considering 38 degrees, the relationship of this side here and this side is actually tangent, right? Opposite over adjacent is tangent. So if we try to take the tangent of 38 degrees, okay, it should be h all over 30 minus x. See. Okay, we are not using sine law, right? So computing for h now will be tangent of 38 degrees times the quantity times 30 minus x. Or h now will be 0.78129 times the quantity 30 minus x. We call this equation number 1. We are given, we have now formulated the first linear equation involving two unknowns consisting of h and x. And again, by covering the left triangle, considering the right triangle, meaning the triangle on the right, the relationship of this side here with respect to this is again tangent, considering the 71 degrees. So using the right triangle, okay, tangent of 71 degrees will be h over x. H over x. So h now will be x times tangent of 71 degrees. Or this will be h equal to 2.90421 times x. We call this equation number 2. So we have now formulated the second linear equation involving h and x. Okay? Oh, that's a conventional solution without using sine law. Equating h is equal to h, this is now a part of algebra. We are solving two simultaneous linear equations involving h and x. So equating h to x equal to h, the first equation is 0.78129 times the quantity 30 minus x equal to the value of h using equation number 2, 2.90421 times x. Okay? Then I would like to eliminate this one here, 0.78129. So I will multiply the whole equation by 1 over its reciprocal, 0.78129. I want to eliminate this. So the left hand side multiplied by 1 over this portion here cancels. So what remains on the left will be 30 minus x equal to 2.90421 times 1 over 0.78129, it's 3.7172. The coefficient of the right hand side now after the division will be 3.7172 multiplied by x, Okay? So we transpose this to the right, then we rearrange. This is 3.7172. After the transposition, this will be plus, so it will become 4.7172 times x equal to 30. Solving for x now will be 30 over 4.7172. And what will come out for the value of x is 36 inches. So this value of x is 6.36 inches. And so solving for h by using equation number 2, it is much simpler. H now will be 2.09421 times 6.36. And the value of h will be 18.47. Sorry for this one. X is 6.36. It should be this. And this is h. Sorry for that one. 18.47. This portion. This is 6.36. Okay. To compute for the value of B, and A now, again, you cover the right side right triangle. Okay. We are now given the height. We are given this angle, and we will compute for the hypotenuse of the right. It seems B is the hypotenuse of the left right triangle. So the relationship of H and B is actually sine considering 38 degrees. So if we try to take the sine of 38 degrees, it will be hypotenuse over the unknown side B. Sine of this will be hypotenuse or the height computed divided by the hypotenuse. It seems B is the hypotenuse of the left right triangle. So B now, small letter b, will be equal to, we manipulate this one. This will go up, this will go down, so it will be h over sine of 38 degrees. It should be, h is 18.47. Sine of 38 is 0.61566. And if we try to divide this one, I use my calculator. This is exactly 30 inches. Okay? From the previous solution using the SINE law, the value of B is 30 inches. So by using the conventional solution, still the value of B is 30 inches. Okay? And by covering the left right triangle, we cover this one. We will solve for A. Considering this side here and this, it will still be sine, right? So if we take the sine of 71 degrees, it will be h over A. Sine of 71 degrees, considering the right side right triangle, it will be h over A. And if we try to compute for A will go up, this will go down. So A now will be equal to h over sine of 71 degrees. It will be 18.47. Sine of 71 is almost 1, 0.9455. And if we try to divide this one by using our calculator, the value of small letter a is 19.53 inches. I think this is the same as from the previous solution by using SINE law. That's it, guys. At least we now know that the SINE law solution was correct by using the so-called conventional solution. This is the conventional solution by using our knowledge of the so-called definition of trigo functions. Okay? It is not SINE law. It is just a conventional solution. You try to subdivide the given oblique triangle into two right triangles, then use your knowledge on the so-called definition of the functions. Okay? You try to make representation on the unknowns. Okay? So we represent this as x. We computed it, 18.47. This is x. It is 6.36. Okay? To compute for the value of b and a. For the first one, the relationship of b and h is actually sine. Because considering 38, this is opposite, this is hypotenuse. Considering the 71 degrees, this is still opposite side, and this is hypotenuse, considering the right side right triangle. So we actually use the sine function. Okay, that's it, guys. I think this will be a good illustrative example on the so-called computation of problem solving involving right triangles. Okay. For those of you who would like to subscribe to my channel is at youtube.com/@ProfDavidJDelosReyes. If you want to share it, please click share. I will assure you, my long video format discussion, you will learn something from it. Good morning.